My camera shut off. I did not feel like starting over, so we're going to pick up where we left off. Is 10,4 a solution of the system? 10,4, that's on the solid boundary, so yes. Let's look at another example. This time, we don't have horizontal and vertical lines. We have in slope-intercept form. We love it when they're already in slope-intercept form. We don't have to solve, we can just graph. Start at 3, the y-intercept. My slope is 2 over 1. Rise 2, run 1. As I said yesterday, it's really good to use a straight edge, which Miss Jones is not currently doing what she says, and make it straight. Oops, I forgot to check and see if it was solid or dashed. Line under it, I'm in luck. It's solid. This is why we use pencil. If I had messed up, I could have erased. Now let's look at the other one. Start at 1. And my slope, there's an imaginary 1, is negative 1 over 1. Make sure you make it a nice negative when there's a negative there. Down 1 over 1. So is this one dashed or solid? It is dashed because there's no line under it. We're going to make this dashed. We forgot to shade, we being me. So on the first one, where does y get less than, smaller than the points on this line? We'll look at the y-intercept. Where is it getting smaller? 2, 1, 0. On this side, shade this whole side of the pink line, the whole side. I like to do mine in 2 colors. It makes it easier to tell. If you want to do that after you're confident that you have the line right, if you want to use like colored pencils or something and do different colors, that might help. So this one's also less, but where does y get less? Look at your y-intercepts, 0, negative 1, down here. Shade this whole side of this line. Where did it get double shaded? It's kind of a triangle down here. This is double shaded. Is 0, 0 a solution? Why, yes, it's in the double shaded area. Is negative 2, negative 1? Yes, it's on a solid boundary. Is 2, 7? Well, it's on a solid line, but it's not a boundary of the double shaded part. As a matter of fact, it's nowhere near the double shaded. So that is a no. Let's look at the next example. This one is not solved for y. We have to put it in slope-intercept form. Get rid of the x. 2y is less than negative x plus 6. Excuse me. Divide by 2. You must divide everything by 2. Here's where a lot of you mess up. There's an imaginary 1 you don't need to forget about. So your slope is negative 1/2. So let's go to 3 down 1 over 2. We can also go up 1 and left as long as we make 1 negative move. Is this dashed or solid? Why, it's dashed, Miss Jones, because there's no line under it. Where does y get less? Y is smaller as we go 2, 1, 0, we go down here. So let's shade the whole underside of this line where it's getting less. Then we must solve this one for y. Subtract your 3x. Did you notice they switched this one up on you? The x and y weren't in the right order. Don't get tricked by that. Minus the 3x, and don't get tricked by the negative there. The minus goes with it, making it a negative 1y. Now I divide by negative 1. When I divide by a negative, what happens to this? It flips. So I'm going to start down here at negative 4. This is 3 over 1. I'm going to go up 3 over 1. They actually intersected a nice little point there, but that's not our solution. Dashed line, because there's no line under it. And then we're greater this time. Where does y get greater? Start at your y-intercept. It's going greater when it gets up to the bigger numbers. 1, 2, 3. Shade this whole side of that line. Now, where's your double shaded? your double shaded's right here. It almost makes a little triangle again. Is 0, 3 a solution? It's on a boundary, but it's on a dashed boundary. No, it's not included. Is 0, 0 a solution? Yes, it's in the double shaded area. Is 2, 2 a solution? This is the point of intersection of the two lines, but they're both dashed. So no, if one of them had been solid, then yes, we could have included it. But since they're both dashed, then no, it doesn't get included. I'm going to stop there and not do the last example, and then you can work on your assignment.